Hi, good day to everyone. Myself Lilawati Apung from Murugan. Today, me and my friends Dineshwini and Prasad would like to present about reverse transcriptase polymerase chain reaction, which is RT-PCR. So, in our presentation today, we're going to see about the introduction of RT-PCR, the aim of the RT-PCR, the methodology, the result, and discussion along with the conclusion. Let's get started.
Introduction to introduce whose DNA it is. Okay, the year 2020, the beginning of COVID 19, where it begins in Wuhan, okay, in China. So, in Wuhan, China, what happened? 31st December 2019, the first COVID death reported. So, then this WHO, what they do? What virus it is? It is coronavirus. What is coronavirus? It is the merge of MERS-CoV and the SARS-CoV-1, which take take the shape of, take the when it merged, then it produces that SARS-CoV-2, which will be the disease of COVID-19, and actually the main person to play the role will be the coronavirus. Okay, then after our WHO, World Health Organization, they know, okay, this is coronavirus, and we can notice that it will be transmitted through all this sneezing, coughing, then you handshake with someone, airborne, so it's very contagious. So it is contagious, okay, it's already get to someone. How we going to test a person with coronavirus, where the coronavirus DNA already entered his body? How we going to identify that? Then WHO requested all the laboratories around the world, especially, as personally I read, Australia. They will be taking, they were taking all the actions to find out how. Then all the laboratories, then this WHO, after they fathom out a figure, fathom out a solution, they come out with this solution to identify, okay, not to treat, but identify the coronavirus DNA in our body. So they use this RT-PCR, which is rapid test polymerase chain reaction method. So this method, it can show us that there is a coronavirus DNA in your body and how severe it is when you test using a PCR method. Okay, this will be for the introduction, and how and what are the ranges, all will be explained by my group members.
Today I will be presenting about the aim of PCR, which is a specific DNA segment can be quickly multiplied into millions or billions of copies using the polymerase chain reaction, which allows for more in-depth analysis of the DNA in PCR. A section of a genome to be amplified is chosen using short synthetic DNA fragments called primer, and the segment is amplified using several rounds of DNA synthesis. Now I will be explaining about the methodology, which is PCR process have 4 steps, which is collection, preparation, amplification, and post PCR cleanup. The PCR machine steps happen in the amplification step. It begins with a segment of a DNA sample placed in a suitable tube along with the reagent and chemical listed. The tube is placed into the PCR machine or thermal cycler. The thermal cycler takes the solution through a 3-step process, which is denaturation, annealing, and extension. This is the PCR process workflow, which is from sample extraction, and then divides into two, which is qPCR process and endpoint PCR process. So I will be explaining about the steps. First step is denaturation. The solution contained in the tube is heated at least 94 Celsius using a thermal cycler. The heat breaks the hydrogen bonds of the original DNA sample, separates the DNA into a single strands. Steps 2 will be annealing. The sample mixture is the cold to be to between 50 to 16 Celsius, allowing the DNA primers and the DNA polymerase enzyme to bind to the individual strands of DNA that were separated by the heat. At this point, the nucleotides from the added mixture solution will pair with the individual separated strands of DNA that resulted from the heating process. Step 3 is extension, which is once joined together, they form a new complementary strands of DNA. Thus, a new duplicate double-stranded DNA molecules has formed from each of the single strands of the original sample molecules. The temperature cycles from 95 Celsius to 50 to 60 Celsius. The cycle is then repeated about 35 to 40 times using the thermal cycler, which automatically repeats the heating and cooling cycles of the process. Resulting DNA sequence is doubled each time the heating cooling cycle is conducted by the cycle. Thus, what started out a single short segment of DNA from one sample can be amplified to form millions of copies after 35 doubling cycles. Step 4 is analysis with electrophoresis. Once the PCR process is completed, the resulting amplified segment generated can then be compared to other nucleotides segments from a known sources. PCR generated nucleotide sequence are the placed next to known nucleotide sequence from humans, pathogen, or other sources in separating gel. Electrical current is the run through the gel, and the various nucleotide sequence within the gel form bands that resembles a ladder according to their electrical charge and molecular size. This is termed gel electrophoresis. Bands or ladder-like steps that migrates to the same level in the gel shown identity of nucleotide sequence. This method is one of the most popular ways PCR tests are completed. And then this is the example of PCR temperature cycle, which the total program length is 1 hour, 12 minutes, and 3 seconds.
Thank you for Dineshini for explaining about the methodology. Now I'm continuing with the result of RT-PCR result. So here is the summary of result in the form of a contingency table. So this is how a result is interpreted as positive and negative. As we can see, PA stands for positive agreements or true positive, ND stands for negative deviation or false negative, PD stands for positive deviation, which is false positive, NA stands for negative agreement, which is true negative. So as for the summation, and that's the symbol N, positive and negative. Following with another result, this is what we can see as per the graph shown in RT-PCR. So there will be line formation, expositional PCR phase, and the background noise, and also threshold adjacent to fall within the PCR exponential phase. This is the example of result in data. So, explaining about the results, when all control exhibit the expected performance, a specimen is considered negative if all virus COVID markers N1, N2, N3 cycle threshold, growth curves do not cross the threshold and the RNSP growth curves does not cross the threshold line. When all the controls exceed the expected performance, a specimen is considered positive for COVID-19 virus if all markers, which is N1, N2, and N3, cycle threshold growth curve crosses the threshold line. The RNA-seq may or may not be positive as described above, but the COVID-19 virus is still result as valid. Followed by when all control exhibit the expected performance and the growth curves on the virus COVID-19 markers, which is N1, N2, and N3, and the RNase and P marker do not cross the cycle threshold growth curve, the result is invalid. So if the tested sample is negative for all markers and all control exhibit the expected performance, the result is still invalid. Lastly, when all control exhibit the expected performance and the cycle threshold growth curve for any one or two markers, for example N1, N2, or N3, but not all three crosses, the threshold line, the result is inconclusive for virus COVID-19. Re-extract RNA from residual specimen or retest. That's what we can explain from the result as we can see earlier, which is this one. So I'm passing to Prasad to conclude this presentation.
Already got, not to say 100%, but 80% how this PCR is working on. So as for conclusion, the reliability of a test for COVID-19 detection depends on the accuracy of the result provided by the laboratory. How they going to handle these samples, the transportation of the sample is very very important. You can't be placing the PCR sample under the sun just for 3 to 5 hours. No, cannot. There are certain temperatures you must handle the sample with that certain temperature. And how are you going to test? The methodology just now already explained by my member. How are we going to handle it? If you handle it properly, then the accuracy of the result will be 100%. No, it will be 99, maybe. You can't be saying that the result is 100% yes, perfect. No. So it will be 90%. You already get an accurate result. So the reliability, it depends on the laboratory and how the technician is handling the method. And when the range of PCR is higher, like 40, 35, 36, the activeness of the virus is low. When the range is getting down, the activeness is getting high. So you must understand, and it is very important, bear in our mind that every 4 days, if a person is infected with coronavirus, he or she have to test the PCR for every 4 days to know the severity of the virus. And same goes to how we're going to handle the safety measures. Yep, we already crossed some of the obstacles and we are a bit free from it, but no, it is still new for us. They have a long way for us to go, so we must ensure that we follow the safety measures to keep ourselves and to keep others free from this coronavirus or COVID-19 pandemic. So let us stay healthy and thank you.
Thank you for watching our presentation. Hope you get information from our presentation. Thank you.